Hello, Dr. Oda. Hello, Ian. My name is Sochita Tork. So I am doing the extra credit problem, and I'm going to be talking about impedances for mesh analysis and phasors for mesh analysis as well. So to start off, I did 10.7. I did 10.7 for this problem. Yeah, this homework assignment, and I applied SuperMesh instead of nodal analysis, and I just wanted to see how it turned out. So things to know before I approach this problem is it's phasors. Phasors have complex numbers. Complex numbers take on different forms, so there's rectangular components, polar coordinates, and exponential coordinates. We don't work too much about exponential coordinates. I usually work with rectangular and polar. So for example, z equals x plus yj. Those are two components for one equation component for phasors, and z equals r angle theta, which is another we can write with complex numbers. So also you can convert back and forth between these two equations. So let's say if I want to convert from rectangle to polar, I take the square root of both those components and then square root them, and I find the magnitude of my r. Or let's say if I have it in polar and want to convert back to rectangular, I take that r, cosine theta, whatever my angle is, and r j sine theta, which is my complex number, imaginary, whatever you want to call it. One thing to note is to make your life easier is adding, subtracting is best with rectangular components, and multiplying and dividing is above with polar coordinates. And you want to make sure that you know that, because in these type of problems you convert a lot back and forth just to make your life easier. But a lot of the algebra gets in the way, so I just want to let you know. So there are 4 different quadrants. Also to note for your angles on what you get it on, based off your rectangular components when you convert them. So for let's say for instance, like you get a positive x and a negative yj. You want to take your magnitude of your y and your magnitude of your x, and then you subtract it by 180, and then that would be your angle you use for that polar angle. And then yeah, so I'm gonna get right to the problem. And one thing to note is that this requires a lot of algebra, and you're bound to mess up. I didn't get quite the exact answer, but I do believe that I did my process correctly. I was like 10 volts off of what the answer was supposed to tell me, and my angle was negative, but I spent a pretty good amount of time, and I think I'm pretty proud of where I got for this. So 10.7, you're given the book. There is a current source and a voltage source. You can approach this in any different way: mesh analysis, nodal analysis, or even superposition. And I'm kind of curious how you would apply for superposition to see how it affect your answer. So what I did here is I noticed that there's a current source between a non-reference node. So I'm like, okay, I can just take it out and then apply mesh analysis. So I do I1 in this box, I2 in this box, I3 in this box. And you take out, also when you take out a current source, it is open circuited, so that's why it's open here. And we will use it later on in this problem. So like I said, KVL. So I did my SuperMesh first, and I've noticed, okay, I'm going through the negative side of the voltage source, 120 angle negative 15, plus I1 times 40 and 20J, and then negative J30 times I2 minus I3, because I know I2 is going into that capacitor, and then I3 is going out. So you want to make sure of that, because you want to know your I2 component and your I3. From there, I applied mesh analysis onto the last box for I3. So I did 50 I3, and then I3 times J30 minus I2. Like I said before, I3 is going out, and then I2 is going the opposite way, so you want to make note of that. So yeah, so I got my first equation for SuperMesh, I got my second equation for mesh analysis, and now you have to make note of your super node. For my super node here, I know I1 is going in, my current source is going down, and I2 is going this way. So KCL, I2 and it splits out. So you want to make note of that, and also what you want to find for your voltage, right? So I know my voltage is here, but the only way to find it is by doing a voltage drop. So for my voltage source to V, and you know there's some type of current going there, so it's going to stay constant, and you want to find that. Just to save me on some time, like I said before, it requires a lot of algebra, so I'm going to post my solutions into the description. I think so. Just to show my method on how I did this, so to find V, I need to find I1, and to find I1, I need I2, but to find I2, I need I3, and then I'm gonna have to use this big equation to find what I1 is. Find that I1, plug into this equation, isolate all your variables, so you can find voltage. Your V should equal 120 angle negative 15 degrees minus I1, 40 plus 20J. So basically from doing all that math, I found that my current is 5.17 angle negative 40.01 amps. Since I know that, like I said before, plug into this equation, find your voltage of 137.89, angle 142.06 volts. I was about 10 over what the answer is supposed to be, and my angle is positive instead of negative, and I've learned through it for so long and I can't find the process, but I know how to approach the problem and I know how this works, so hopefully this is sufficient to tell you that I understand it. One thing I would like to do better for this is I want to relate it to different concepts. So obviously nodal was on the homework, and superposition, there's two different sources, so to see how it affects it. And also the algebra, I would like to understand where it goes, but SuperMesh, comparing this SuperMesh to nodal was it was obvious to choose nodal over SuperMesh because how long it was. But yeah, thanks for watching my video, and hope you have a great day.